Here we're going to create the board for our button and light design that we created in the last video. Here's a schematic we created. I'll open that up. And here's the schematic as we left it. This tool up here is we'll either create the board or switch to the board view. Since we don't have a board, clicking on it is going to create the board for us automatically. So select yes when that comes up and it asks. So here's our board. Here are the 4 components that we placed in our schematic. Eagle has put them in there automatically. And this white rectangle is the board outline. And right now it's set to the maximum size that the free version of Eagle can manage. So we can arrange these components however we would like by using the Move tool. So we'll put the button right there. We'll put the power supply right there. Oops. And we'll put the LED and the resistor there as well. So those are our 4 components. Now we can resize the board outline to match more closely the amount of space that we need. So use the Move tool for that to just grab the edges of the board outline. A couple of things to notice here. These yellow lines between the pins on the components, those are air wires, and they represent the electrical connections that need to exist between the pins and the design. But those aren't actually connections yet. There's not real metal there yet. In order to get metal there, we need to route the board. And to do that, we can go right here to the Route tool, click on it, and it knows about these electrical connections. So if we click on one of the pins, it'll start drawing a piece of metal starting at that pin, and then if we bring it over here to where it's supposed to be connected and click again, it'll complete that wire. Now this wire is in blue because it's on the bottom layer, so it's going to be on the back side of the board, as you can see up here. We can also put metal on the top by selecting top, and then we can route this wire here to be on the top of the board. So this is fully manual routing, and it will let you do some kind of silly things. So if I wanted to route this wire here, I can select here, and then I could run it up over here, and like that. And as you can see, it's allowed these 2 wires to cross. And that actually means that those 2 wires are going to be electrically connected, which is not what we want. Those are supposed to be 2 different signals, and so this is going to cause a bug in our board. So fully manual routing is usually not what you want. And to undo the routing, we can go up to the command line here and type rip up semicolon, and it'll ask you if you want to rip up everything. And the rip up just removes the wires and replaces them with those air wires again. So let's do routing in a more intelligent way. We'll select the Route tool again, and then we can select the Follow Me router up here in the routing toolbar. And this is going to be a little bit more intelligent about how it routes things. So again, we can click on a pin, and it sort of tries to run the wire through our cursor, but it makes it a little bit more tidy. And in fact, if I do something here, let's say I'll route this guy over here. And now if I try to make the wires cross again, for instance by running this wire down here, what it's done is it's actually put this wire on the back side of the board, run it underneath this trace up through a via, and then back to the front side of the board, because that's what I told it to do because my cursor was down here, and then also connects it on the back side of the board to the pin where it was supposed to go initially. And so now this will prevent me from creating any of those unwanted electrical connections. I'll go ahead and clean this up a little bit with the manual rip up tool over here. You can just click on these connections and it'll delete them. And then I'll go back with my router and do something a little bit more sensible like that. And we can route the rest of the connections as well. So every time there's one of those air wires, you want to go in and turn that into an actual electrical connection. All right, so that's our fully routed board. There's actually an even easier way to route an Eagle. That's to use the auto router. So we'll rip up everything again. And we're back to here. And now you can go up to the tool menu and select the auto router. And you can just click through the continues here and then start the job. It'll run very briefly because this is a very easy board. Click End Job, and now we have a fully routed board as well. So those are 3 different ways to route the board. Regardless of how you've routed it, once it's done, you need to run the DRC. This stands for Design Rule Check. And it'll run some sanity checks on the board. Now, depending on where you're manufacturing your board, you'll need different kinds of design rule checks. So we need to load the design rule file for the PCB manufacturer that we're going to use. And that's set up here. This is again in our GitHub repository in the DRU directory. You want to use this design rule file. So load that and then hit check. And it tells us there's no errors, so that's good. This is a pretty simple board, so it's not surprising that there weren't any problems. To show you how design rule check works on a more complex board, let's save this design. So we can come back to it later, and then we'll close it. And instead, we'll go over here and load a more complicated design. So this is the reference design for our quadcopter that I showed you in class on the first day. It's a pretty complicated design. It's got lots of stuff going on. We'll learn more about that as the quarter goes on. But we can run the DRC on it right now. We'll go and load our DRU file for our manufacturer, and then we can hit check. And now it's popped up this dialog very similar to the electrical rules check dialog that we saw in the previous video. There's a bunch of different problems. As you click through them, it'll highlight where they exist on the board. You can see they're all down here in one area. So we can close this, and then we'll zoom in on that area so we can see what's going on. And run DRC again to get us back so we can see what the problems are. So all of these, these can represent all kinds of problems. Wires connected that shouldn't be, and so forth. In this case, all of these problems arise because we need to have these components right here that you can see. This is the power transistor that powers the motors. And in order to have the right thermal properties, we've had to create these big pads by hand for those parts. And Eagle's not very happy about that. So if you click through these, you'll see they're all kind of the same problem. Some stuff is overlapping that shouldn't be. And that turns out that all of this is okay. And of course, we had to go through and check this very carefully to make sure we weren't skipping something that was a real problem. But in our case, we can just select all of these and approve them. So you can just hit the top and then start hitting approve and go through and approve all of them. And this means that when we run DRC in the future, it won't bring up this dialog box, and we'll know that any problems that we have, we've already taken a look at. Now, if we run DRC again, check, we get 43 approved errors, which means there are some things wrong, but we've already said those are okay. So that's the process for building a board, routing it, and taking it through DRC.